Hello everybody, my name is Leoshaa Victoria Fernandes from grade 8 and today I am explaining about the topic relative density and measurement of relative density of a liquid. Density. Density is the measure of how compact the mass in a substance or object is. The formula for density is mass by volume. The unit of density is kilogram per meter cube. Density. Relative density is the ratio of the density of the object to the density of water. The formula for relative density is equal to density of object divided by density of water. Relative density can also be written as RD. If the relative density of an object is greater than 1, then the object sinks. If the relative density of the object is lesser than 1, the object floats. If the relative density of the object is equal to 1, the object just floats above the surface of the water. Here 1 refers to the density of water. As you can see, when the relative density is greater than the density of water, the stone sinks at the bottom of the container. When the relative density is lesser than 1, the object floats above the surface of the water, and when the relative density is equal to 1, the object is completely submerged but still floats below the surface of the water. Relative density of a substance is equal to density of the substance divided by density of water, that is equal to kilogram per meter cube divided by kilogram per meter cube. The units for the density of the substance and the density of water are the same, hence they get cancelled out. Therefore, relative density has no units. Measurement of relative density of a liquid. A density bottle is used to measure the relative density of a liquid. This is a density bottle. The upper part is called the glass stopper. The gap in between is called the hole, and the transparent part is called the glass bottle. Let us perform an activity to determine the relative density of a liquid using a density bottle. First, we take an empty dry density bottle and we find the mass of the density bottle using a beam balance. We refer to this mass as m1 gram. Next, we fill the bottle completely with water and insert the stopper. The extra water overflows through the hole in the stopper. The water droplets that overflow must be wiped out using a blotting paper. We then find the mass of the density bottle that is filled with water using a beam balance, and we refer to this mass as m2 gram. Next, we empty the bottle and dry it. We fill the bottle again completely with the given liquid and insert the stopper. Again, if there is any extra water, it overflows through the hole in the stopper and the extra water droplets are wiped out using the blotting paper. We then measure the mass of the density bottle filled with the liquid using a beam balance and refer to this mass as m3 gram. Now we have found the values. The mass of the empty bottle is m1 gram. The mass of the bottle filled with water is m2 gram. The mass of the bottle filled with the liquid is m3 gram. The mass of water is m2 gram minus m1 gram, and the mass of the liquid is m3 gram minus m1 gram. So the relative density of the liquid will be mass of the liquid divided by mass of equal volume of water. Here mass of the liquid is m3 minus m1 gram, where m3 stands for the density bottle with the liquid and m1 stands for the empty density bottle, divided by m2 gram, that stands for the density bottle with water, subtracted by m1, that stands for the empty density bottle. Then we get m3 minus m1 divided by m2 minus m1. Values at places of m1, m2 and m3, then we can find the relative density of the liquid by subtracting M3 minus M1 divided by M2 minus M1, that is here 49 minus 25 divided by 55 minus 25. Upon subtracting, we get 24 divided by 30, and upon dividing, we get 0.8. Here the result obtained is only 0.8 as relative density does not have any units. This was all about relative density and the measurement of the relative density of a liquid using a density bottle. Thank you.